So before we get into the story of Beaker, let me kind of give you a little bit of context about myself. I've spent the last 14 years at Two Sigma Investments where I really focus on two things. One is solving really what we think are very hard problems in data science, and maybe perhaps more interesting, identifying the next set of next generation of problems that we're going to need to solve in order to be a convincing quantitative investment manager for the 21st century. And that's in my role as Chief Innovation Officer, which is not Chief Inspiration Officer, which is what was noted in the speaker notes here. But I think I actually like that better than Chief Innovation Officer, so we'll go with that one. So Two Sigma is a data-driven investment manager. What we do is we form hypotheses about tradable instruments, and then we apply the scientific method to those hypotheses. We add lots of data, we stir in a splash of algorithms, a lot of human ingenuity, and we do that to understand trends and to forecast the future. That's basically what we do. I am a gypsy fortune teller for the 21st century. My background is nothing to do with finance. It's as a trained physicist and a mathematician turned computer scientist. And really, my problems began right there. As a physicist about 30 years ago, I was doing my master's thesis, and I was reading a paper. I'm sure like many people here who've read papers, and there was an error in the paper. And first of all, you spend a week figuring out whether it's you or the paper, and then you're like, whoa, this is publishable. I can publish that someone else made an error. And so I did, and it got me, it got me a fair mileage out of it for my own research. But mathematics is by design a solitary occupation. And some of the ramifications of that are that errors can lie undetected for years before being picked up. And that really bothered me. But I never really understood what to do about it. And really, the whole thrust of Beaker is me thinking about this problem for about 30 years and trying to understand how we can solve it. So my default method of understanding the world, probably like most of you, is as a Bayesian statistician. So that is like this process of taking recent observations, incorporating them into a model of the world that we have now, updating that model, and using that model to predict the future. And we do this all the time. If I asked you what the next thing to come through that door is, my guess is that everyone in the room says a human being, right? Not, for example, a dog or a cat. But in the US, the population of dogs and cats is about 1/3 of the total population of dogs and cats and humans. So as a frequentist, I would say there's a 30% chance that a dog walks through the door. But we know that's not true because we're implicitly Bayesian. We kind of understand from our model of the world that dogs and cats don't wander around the halls of this hotel. And even in New York, dogs and cats form about 10% of the population. So it's a pretty good chance where I come from. So over the years, this Bayesian in me gathered enough evidence to take a stab at how to begin solving the problem that I first saw 30 years ago. And I developed with my colleagues at Two Sigma into a larger vision for collaborative data science. And we call this larger initiative internally Bunsen. And I'll come back to that in a minute, but that's the German chemist, Robert Bunsen, who invented the Bunsen burner that I had so much fun with when I was a kid. So the process of data science is still today incredibly compartmentalized, right? But if you break it down into its kind of core components, then you can spot a process that everyone goes through. The first thing you have to do is get a hypothesis, right? So that's kind of fairly straightforward. And that's where your problems begin. Because once you have a hypothesis of data science, what you then need to do is find data to prove or disprove that hypothesis. And maybe you work on your hypotheses given a data set. But if you don't, you have to find a data set for that. And that is complicated. But let's assume you find the data set. Then you overcome the technical problems that we all have of ingesting that data set, of downloading it. And at Two Sigma, we've taken delivery of servers of data. Not just FTP, but of servers, of hard drives, of any way you can get it to me, even paper. I'll take the data if you can get it to me that way. And so you have to ingest that data and normalize it. And once you've done that, then you get to the juicy part. There are like loads and loads of these great analysis tools, many of which now run in Jupyter. But collaboration is really complicated. So you might speak Python. I don't. I speak kind of Perl. I'm kind of old. A bit of Groovy now. I don't really speak Python, and I have colleagues who speak R or MATLAB. And the only way to collaborate with someone who speaks a fundamentally different language than you is to either believe what they're telling you to be true, or to just redo the whole thing yourself. And that's what we do, right? So we'll take your R code, I'll rewrite it in Python just to make sure that it works, and like, okay, that's good. But it's a tremendous waste of time, and it's not real collaboration. And when you do that, you introduce the possibility of more bugs and a lot more time in the process. But suppose that we can actually collaborate effectively. So we both speak Python, and we can kind of collaborate effectively. Then as data sets kind of grow in size, we're going to need computing power. And so we need access to computing power that is greater than we have on your typical laptop. And so you need access to a variety of different compute resources in the cloud, which is available, but kind of non-trivial if you want to spin up, even today, say a Spark cluster in Google Cloud. Like, these aren't trivial. They will one day, but they're not trivial yet. And so, you know, you're all sitting here, so you're on kind of this leading edge of technology and data science, but the vast majority of scientists are like way in your rearview mirror. But let's assume that you can do that. You can do the analysis, you can do the collaboration, you can get things done. Then the results look good. Then what do? You have to actually publish it, right? And here, in case you didn't notice, publishing hasn't actually changed since kind of movable type about 1,000 years ago, right? What we see today, even on the web, the publishing is kind of fairly boring. It's static. When you publish in a journal, or even if you publish online, what you get is a static snapshot of the science that you did. But worse than that, your science is your research is effectively not just ended, but kind of dead, right? Anyone who's ever tried to reproduce a paper will know that, right? You scratch your head. I just can't get. Why? Because the data is not contained with the paper. And even if you got the data with the paper, the code that they use to analyze the data is not with the paper either. So we have a really big problem, and we need to fix that. And that's what really Bunsen is. This is the vision that we have for data science, or that we had for data science when we introduced Bunsen. The first thing is discoverable data. Data should just be easily discoverable, and by that I mean not just kind of typing into Google, where can I get cargo manifests, but being able to ingest them in a fairly straightforward way into something where you do your data analysis and modeling, in this case, a notebook, Jupyter, or Beaker, and hopefully BeakerX, as we'll see later on. Once you're doing that data analysis and modeling, you need access, straightforward access to scalable distributed computing in a way that you don't need to think as a data scientist, how many cores do I actually need for this? Do I need to be running on a GPU? You know, what kind of framework am I going to be using? So at 2 Sigma, we've been kind of doing this for about a decade. We have a fairly straightforward notion of data at 2 Sigma. If you can name the data somehow, then you can use it. And you can use it in any of the analysis tools that we provide. The data analysis and modeling portion of the research process has been enshrined in a notebook. And that notebook we called Beaker. That is what Beaker is. And analyses in this notebook are very, very tightly, at 2 Sigma, very tightly and invisibly integrated with scalable distributed compute of multiple types. And finally, critical is the ability to publish and have ongoing collaboration with your peers. So basically, a research and publishing platform for the 21st century. So in any scientific venture, you know that the key to success is actually writing things down, right? It's about publish or perish. And we record so we can understand our own thought processes and eventually find a clear line of research among the very different false starts that you might take. And we share our thoughts and our ideas with others in order to build this body of knowledge that more accurately describes the world we live in. We build on the work of others, and we stand on the shoulders of giants and move the community of scientific research forward. And so though we hadn't actually met and we were separated by the entire width of the United States, it's kind of amazing that back in 2013, so well before Jupyter, this is kind of IPython days, Fernando and I had very, very similar ideas about how notebooks can be used to exchange ideas. I was an admirer of IPython, but I had other ideas of my own. See, I love using physical notebooks. I'm a bit of a notebook hoarder. And for me, that kind of ability to go back, to have a look at what you've done, to look at the arbitrary doodles that you did on the page, the computations that didn't quite work, there's something quite magical about that. But take a good look at the notebook in this picture, and what you'll see is some kind of non-linear amalgam consisting of multiple different kinds of visualizations and language. Spend a few seconds just looking at the image and imagine what you could do marrying this paradigm with digital notebooks. So a key observation from looking at the notebooks is that language actually really, really matters. So it's said of one of my favorite quotes of Charles V, that if it was necessary to talk with God, he would talk in Spanish, which language suggests itself for the graveness and majesty of the Spaniards. If with friends, in Italian, for the dialect of the Italians was one of familiarity. If to caress someone, in French, for no language is tenderer than theirs. And if to threaten someone or to speak harshly to them, in German, for their entire language is threatening, rough, and vehement. I'm not a German speaker, I don't know, but this is Charles V. But the quote really enshrines this idea that languages, they're not isomorphic. Like that's a kind of a key point. Different languages are particularly good at conveying certain ideas, and computer languages are no different than human languages. So knowing a single language today is just insufficient to be a data scientist, right? You've got to know Python, say, to talk to your data, Spark to talk to your distributed clusters, LaTeX if you want to kind of bring up some mathematics. Let's not forget English and Markdown and all of the various different languages that you're going to actually use to compute your ideas. So it was clear that any notebook experience would require what we call a polyglot solution in order to be truly collaborative. And I want to distinguish polyglot from multilingual. It's something that the 2 Sigma people tease me about no end. Multilingual, which is what we have currently in Jupyter, is the ability to have multiple notebooks, each one in a different language. That's a multilingual platform. A polyglot platform allows you to change languages in the middle of the notebook. And that's what really the key to Beaker was, that one cell could be in Python, the next cell could be in Clojure, and you can transfer data seamlessly between them so you can really collaborate on a granular scale. So the Beaker Notebook was kind of core to this vision of collaborative open data science, and it was our first release, our first step towards Bunsen. So it's been very successful. Inside 2 Sigma, most of our modelers use it to collaborate on their research. It's really collaborative, and at last count, supports more than 10, at least 10, right, Scott? 10, 12 different languages, Python, R, Scala, Clojure, as well as Markdown, LaTeX, HTML, rich text, lots of stuff. But it was much, much more for 2 Sigma, as I said, than just kind of this stepping stone towards open data science. For us, it was a major step into the community. It was our first open source project, a major step coming from a secretive financial firm. We had literally to create a new way of interaction in order to effectively engage with the outside world and engage further with the wider open source community. So we released the beta in May 2014 when we spoke in New York. And then a year later, we released the Beaker Lab Alpha, which is a small step towards Bunsen. But we were really learning all the time and struggling to keep pace. So I'm going to talk a little bit about what I've learned in the last couple of years. So from our users. So this is actually about the size of the Beaker team. It's small. And usually Scott jumps between different things, pulling wherever he can. We've had many Beaker fans at 2 Sigma and outside, but we've also had critics, right? Attempting to satisfy this decade of kind of internal tools and analytics, along with all of the new innovation, especially from within the Python community, was really hard. And the Beaker team found it just difficult to keep up with the pace of innovation on IPython and then on later Jupyter. It seemed every day there's this kind of new feature that our internal and external users really, really wanted and to take advantage of, but it wasn't available. So we saw the internal use of IPython just keep growing, and then Jupyter came along and like everything just blew up. We began to doubt whether we could really keep up. You see, Okay, so from our open source world, we learned a huge amount. It was the first open source project that we've done. We've now done 20, less, more, 15, something like that, including some really great analytics. One of the things that we've learned from the open sourcing was it's actually very difficult to build a community around a project developed by a single entity, right? We all have day jobs. It's actually really, really hard. Now we got Wes at 2 Sigma. My hat goes off to him to be able to build a pandas community. It's stunningly difficult to do that. And while the number of Beaker users did grow over its 3-year life, that growth just paled into comparison with Jupyter. Because we were Bayesian, we assumed that the future looks a little bit like the past. And if you look at IPython and Jupyter before 2014, there's a beautiful straight line going up a little bit. It's great. If you look at the adoption of Jupyter after 2014, it just takes a right turn and goes straight up to the roof. There's an exponential. And so we completely missed that. So building a community is difficult, and more difficult once a large community forms around a single great idea. It's just hard for a single entity to keep pace. So while the implementation wasn't growing as we imagined, the vision was right. So everyone in this room and everyone in this building has affirmed that the power of this original idea for an integrated environment that was language agnostic. And in fact, looking at the talks featured here in JupyterCon, most implicitly or explicitly support part of this vision that Bunsen was. So as I said, a good Bayesian updates their priors, and once that is done, you know exactly where you're meant to go next. So if you don't like statistics, let's talk about compute. If the original idea of Beaker was kind of a fork from the early days of Python, it became fairly clear that it was time to merge and join back with the original community. And so somewhere late last year, we realized that really to succeed in delivering the vision, which is what we wanted to do, we had to kind of roll back into the mainstream. And so there we go. That was the pivot. It was really hard for many, many, many reasons. But as with any scientific theory, the idea is to take the best of what you've got and apply that to the future. We knew that Beaker was good, and so the next thing to do was to bring that goodness to the Jupyter community. And when Jupyter Lab was announced, we saw the opportunity to jump on board and present Beaker not as a standalone editor, but as a set of extensions to Jupyter Lab in a much larger community. But, it's pretty scary to take 3 years of work and just pivot into a completely new direction. However, I guess I'm standing here to tell you that we did it. And not only did we do it, but it's kind of fairly impressive number. So this number, which is one of my favorite numbers in the whole talk, 94% of the code that's in the BeakerX extension comes from Beaker. So we had to add I say we, every time I say we, it's Scott and TZ, who are sitting in the front row, had to add about 6% of what currently is in the BeakerX extension is the glue that we needed to roll this into Jupyter Lab, and that's really a testament to the APIs that Jupyter Lab presents for its extension and the way that we built the original Beaker. In terms of the original Beaker code, we actually lifted that 94% represents about 50% of the original code. What we threw out were actually the things that we're just actually not that good at, which is all of the UI and the infrastructure around the UI to present what we really wanted to present, which was actually the cells. So the pivot, we believe, is great for our product, that we can get introduced to a much wider audience, and we hope it's good for the Jupyter community too. So what do we have in BeakerX? A few things from Bunsen: data discovery, a Java kernel, true polyglot analysis, some great time series visualizations, and some of the collaborative publication that we talked about. But we get so much more because we get you. We get the Jupyter community. And that's a unique addition to our strengths at 2 Sigma. We want to leverage the expertise that you bring while bringing our own expertise, in this case, our polyglot support and widgets for data discovery and time series plotting. But in addition to the features that we bring with BeakerX, the project is about continuing to grow on the path that 2 Sigma set out, which is to continue to meaningfully engage and grow with the open source community at large, and more specifically with the Jupyter community. So we formed partnerships to that end with Continuum, with NumFocus, and the Jupyter Core community. And we consider that to all be part of BeakerX. This February, for example, Brian Granger and Jason Gratt and Chris Colbert joined us at 2 Sigma for a hackathon where we had about 30 or 40 of our developers hacking on projects in IPython, Jupyter Lab, and some of the IPy widgets. So that was pretty cool. But the challenge is actually much, much larger than Bunsen or Jupyter, 2 Sigma, or the community, because the challenge here is to bring the research methodology of science into the 21st century. We have this unique opportunity not only to contribute to this ecosystem, but to actually shape it. Not all scientists are engineers. I had this conversation with my brother-in-law a couple of years ago. He is a professor of neuroscience in Minnesota who had a 10 gigabyte data set. That's small by anyone's standards. And he wanted to do some analysis on it, but it didn't fit on his MacBook. So I said, that's easy. Just grab a couple of instances from EC2, put up an HDFS cluster, you can write some pig, and like Bob's your uncle. And he looked at me and he said, God damn it, I'm a scientist, not an engineer. He had no idea. He's like, I don't want to deal with all of that stuff. We can do that. We can provide it for them. We want to help create this open science publishing platform of the 21st century that will be interactive and will be complete. Something that will genuinely let scientists of today collaborate with each other, not just across space, but also across time. Imagine being able to kind of fork a copy of Ramanujan's notebooks in the 21st century and kind of work on them. That's pretty cool. So we've got about 10 minutes left. 10 minutes left? 15. Excellent. Awesome. We might even get a chance for a couple of questions at the end. Let's do a quick dive on BeakerX, and I'm going to ask TZ to come up and do some demos with me. So the Jupyter architecture that may or may not be familiar to you all is fairly straightforward. You have your JavaScript web clients and widgets that speak via HTTPS or WebSockets to the Python web server, which then talks to its kernel 0MQ or SIGINT to interrupt it, and some of the widgets also work on the back end. What we've done is extend this just a little bit. So we have added our own widgets, tables, and plots. And then on the front end, we've added this notion of auto-translation and publish. And then on the back end, at the back, we have multiple kernels, and we do that with this kind of two pieces of architecture, a base kernel, which contains about 90% of code that you would need to do a kernel in any language, and then a little bit for language-specific stuff. In this case, the example there is Groovy. So let's hit the demo, right? Let me see if I can bring up the demo. Boom. OK, so we're going to do 3 demos very quickly. The first one, I'll get my notes here. The first one is going to demonstrate really the whole process, finding data, doing the analysis, and then publishing in kind of one fell swoop. The second one is going to demonstrate some of this polyglotness, in this particular instance, between Python and JavaScript. And the third one will demonstrate a new kernel, in this case, the Groovy kernel. All right, so let's hit the first one. This is a data catalog demo. So what you can see is that up where the mouse is pointing, we've added really 3 buttons. The first one is the common share button that will allow you to share this. The second one is the data browser, and the third one, which is kind of more technical, allows you to run the initialization cells. So let's pull up the data catalog. So this is a standard, we have to go back, right? So this is a standard catalog. You can search, and you can have multiple providers. In each one of these tiles, there's just a little bit about the data sets that are currently loaded, along with any unique identifiers. A lot of these are from Quandl, but we found one from a company called Enigma that provides public data sets, in this case, the Global Food Prices Database. And when you click through on a data set, you get to see some metadata about the data set and maybe a link to the public website. It's so you can kind of click back through and see what the data looked like originally. My favorite part here is, though, at the bottom, there's a Python code example. And one of the nice things about this is you can literally drag and drop this into your demo, and then you can just execute it. And if we do it and it works, then we might get, there you go, you get the data pulled from the provider. So So that's a way of using data inline into your notebook. We're going to pull from Quandl the rupee-dollar exchange rate. So let's do that. It's a straightforward exchange rate. It has an open and a close price. So we can plot those with matplotlib. And that's fine. It's standard matplotlib. It's very static. You can kind of drag it, but you kind of end up just dragging the image. And so this is the Beaker plot libraries. They're programmatic plot libraries. They're fairly simple to use. They're pretty straightforward. And the API is available in every kernel that we actually provide. And this one just does the same kind of thing. And it's a fully interactive chart. So you have crosshairs. You get tooltips if you hover over one of the data points. There are some tooltips there. You can zoom in and zoom out, and you can drag. Double-clicking on the image pulls you back to where you started from. And then you can also filter and highlight very easily the various different data sets. And then if you really want, hitting a right-clicking on this image will allow you to save this as a PNG. And so fairly straightforward, nice kind of stuff. So let's keep going now. We want to publish this. We've done the analysis. We want to publish this. We can push the button at the top. Boom. Let's see. Does it work? Oh, there you go. So it talks in the back end to GitHub, standard gist that you see, except we've changed NBViewer a little bit to allow you full access to the widgets that we have in the plotting library. So that's a kind of a rough and ready, very quick, let's do the analysis and publish and grab the data. Let's have a look at the second one. This is the polyglot demo. So here what we're going to do is we're going to use pandas. We're going to use the Python kernel to pull in data. In this case, the data that we're going to pull in happens to be someone's sleep resources. And we want to plot this, but we want to plot this, say, using D3. So if I'm using D3, I need some magic to be able to get data into the JavaScript. And we do that by having this global variable that we call BeakerX. And so we're putting the sleep and wake values into there. And then using the standard Jupyter magic, we can both get HTML, but here in the D3 portion, you'll note, there you go, where is it? BeakerX asleep and BeakerX awake. We can just refer directly to them. And again, these appear naturally in whatever language you are using. So the global variable can be accessed the way it would. And here it's a fairly static D3 image of someone who clearly gets a lot more sleep than I do. There you go. All right, but D3 is a little bit more exciting than that. So we can write some Python here that will just create an arbitrary graph, like a social network or something like that. And then when we run that through D3, and by the way, these come straight out of the D3 tutorial, you end up with a lovely D3 widget that you can kind of drag around the way you would drag anything around. Finally, the third demo here is the Groovy kernel demo. So it's just one of the kernels. You can see it's Groovy, but we also have Clojure, Java, Kotlin, Python, and SQL that you can just start notebooks in. We talked about plotting. This is the table display. This table display, I am told, is also now available in Python, right? Yep. Awesome. Python and all of the JVM languages. So it's a fairly straightforward table display, but this one also allows for some programmatic interaction. So in this example, we just set some string formats, column orders, and then maybe shrink down the number of columns that we want. But it's interactive, right? So that the first thing that you can do is you can kind of move columns around. You can click on any column and then sort it up and down. And if you click on the left-hand side of each column, there's this large menu of things you can do, the most exciting one being the filter by expression. And there, $1 refers to the value in this column, so you can just filter for, what is it, $, greater than 8. OK, there you go. And you can reference other columns by name as well. So you can look for values in this column greater than the values in the M3 column. The other thing that you can do with this one is you can do what you always do with tables, which is select and copy. So if you select it, you can then copy using the menu up there, table menu, to the clipboard, and then pull up your favorite spreadsheet and paste. And if you paste, you'll notice that while we swiped just the values, we copied over also the names of the columns, which is kind of fairly useful. You can also download to CSV. The tables also allow visual indications, so you can just do straightforward heat maps, but we've also built in the ability to do data bars. Just hit B on any column, and it will bring up the data bar for that column. Some more BeakerX plotting. This is side-by-side histograms, always very useful. And finally, kind of one of the exciting things is adding custom actions. So Jupyter allows you to add tags to different cells. And what you can do in the plotting library, so in this case, run tag is being associated with the cell below, is you can associate the onClick with different tags. So you can run code in a different cell by clicking on a graph. So in this particular instance, let's see if you click on one of the yellow ones, what happens? Boom, orange, okay. I see yellow, maybe it's orange. And so this allows you to kind of build really interesting apps on your notebooks. So thank you very much, TZ, core developer in BeakerX. Let's see. Whoa, okay. So we're in GitHub, and we have a release candidate on GitHub. So we're kind of ready to rock. I guess that's the announcement that we're making here, is that the BeakerX extensions are available for Jupyter today, and for Jupyter Lab, pip install soon. So we've pivoted from our original plan for Beaker into these extensions for Jupyter. But there is one thing that I didn't explain, and that is the original choice of the name of Bunsen for our project. So Robert Bunsen, besides, I was a bit of a chemist blowing things up when I was a kid, besides inventing a fair amount of science, is renowned, maybe not renowned, but he is actually one of the few scientists that I ever found who never booked a patent in his whole life, because he believed that all science should be free. And so when we were looking around for a kind of a name for this project, I felt that kind of echoed with everything that we wanted to do, that science research, open science should just be available and free for all of humanity to kind of move forward together. So thank you very much. So I have like 2.5 minutes for questions?
Yeah, like 3-4 minutes for questions.
But the good thing is that we're sponsoring the coffee break, so we're going to be around. So if we don't get a chance to answer your questions, come and find us. You get to choose.
Could you explain in a bit more detail the difference between just a regular traditional magic extension for running a cell in a different language? And I saw the Beaker, kind of the reference to Beaker in there, but I didn't quite see
Right.
what exactly they're doing versus.
Right. So I will. So on one foot, and then Scott's going to jump in if he thinks that I've misrepresented. But on one foot, we have there is a global variable that allows you to pass the data from one cell to another. But the way we have cells in different languages is using the magic, because that is the way Jupyter allows you to effectively override the language that the cell is speaking. The data is through the BeakerX. That's correct. Not yet. Not yet, and it will likely do so, because you can imagine that if I'm trying to pass data from a Python to an R, I don't want to do it in a data frame. I want to do it in a format that is agnostic to the data.
Yeah, if I could just add a few words to that. As we've been, auto-translation was one of the more difficult parts of Beaker to port into Jupyter, the polyglot stuff in general. And so, so far, that's only partly implemented. And so, the further implementation will use, the final implementation will use Arrow. But right now, we have a simpler version that just uses JSON. And so that part is still very much in progress. The JVM kernels and the widgets are all sort of production ready.
So with Arrow, you would share the memory?
That's right.
Yeah. Sorry. Yeah.
So I noticed in one slide, you didn't really touch on it, but you had something called the kernel manager. Could you explain that a little further? Is that you ripping out a lot of the kernel management stuff
server, and if so, is that part of what you've open sourced?
The kernel manager is standard sort of traitlet extension of the server, and that particular class is used to set up the parameters for the JVM. So one that allows you to like configure the heap size and set Java properties and stuff like that. And so that's pretty much what that's for. And yes, it's open source along with all the.
Yeah, everything is open source.
Not a separate instance from.
Not a separate instance. It allows us to control, add extra parameters to the JVM that are not in the kernel.json file.
Right.
And those can be currently those are configured with environment variables, but we have in progress like GUI, like another panel of the tree view to add the typical parameters.
My question's about sort of usage patterns. So how like polyglot do people tend to go? Is it like one language bit of another one, or do people have really fully multiple language networks?
So, yeah, I gave the whole talk in English, right? So we generally tend to use one language, and I would expect that. I don't expect multiple cells. Sorry. I guess my 40 minutes are up. However, you know, there is a real use case for this that we talked about at length at the beginning, which is education. So if you do your first data science course in Python, where you learn all of your file manipulation, and then you move to take an advanced data science course in MATLAB, why would you want to learn file manipulation in MATLAB? Like, why wouldn't you want to just do everything you did in Python and then use MATLAB for the stuff that it's good at? Because it's, you know, or R, like I'm not going to go there. But so I think there are valid use cases where you would write some significant portion in one language before moving to another.
Okay, I want to stop there. It sounds like Matt and his colleagues will be around if you have more questions, but I want to thank them and let you know that we're having a break, coffee and things upstairs, and talks will resume at 4:10. Thank you, Matt.
Thank you.